Okay, so this warm-up is on page 15. Try it first before watching the solutions. My only hint to you is to sketch a picture to help figure out what type of transformations happen before you write your equation. So for number one, if I have a vertical asymptote over here at 2, a horizontal asymptote up here at 3, contains the points 1, 2, and 3, 4. I know that my parent function of 1 over x, because they're in opposite quadrants, got translated to the right 2 and up 3. So my new equation, I'll choose f of x for this one because it says a function, is 1 over x minus 2 plus 3. And do the same thing for number 2. We have a horizontal asymptote here at 4. Vertical one over here at -5. -6, 5. -4, 5. So since I have this type of symmetry with the vertical asymptote, I know that the parent function is 1 over x squared. So when I go to write my function, I'm going to have a squared denominator. The asymptote went left 5, so that's x plus 5 squared, and then up 4 for the horizontal asymptote. Okay, last but not least, here's my vertical asymptote, my horizontal one, -2, -6. 0, -8. So normally the parent function of 1 over x is in the top right and bottom left. So I know this one has a reflection over the x-axis, goes down 7 and left 1. So reflect, left 1, don't need those parentheses, down 7. Sorry, you don't need those parentheses. I was thinking of that one, but no squared because they're opposites. Okay, so today we're going to do more graphing with transformations. I've given you the little table over here to help with plotting your graph. I like to start with my vertical asymptote, which does not exist. 1, 2, 3. So I make a dashed line. And then to get nice values for my graph, I go 1 unit to the right and 1 unit to the left of my vertical asymptote. So we're going to substitute them into the equation. Your quiz is no calculator, so you should get used to calculating these y values algebraically with no calculator. Okay, so then I'm going to dash my horizontal asymptote, 1, 2, 3, 4. Plot my points. Make a nice sketch, approach your asymptotes. And now let's fill in the properties. All real numbers, x cannot be the vertical asymptote. Range is all real numbers, y cannot be the horizontal asymptote. So I still have my asymptote equations ready to go. Left end behavior is as x goes to -infinity, my y values approach -4 this way. And right end behavior as y approaches infinity, as x approaches infinity, y approaches -4. The transformations, we go left 3, down 4. So writing this in this notation, A is the dilation, vertical dilation, H and K are the transformations. H is left and right and K is up and down. So g of x is my f of x function gone left 3 and down 4. Because this is f of x. The original 1 over x went left 3, down 4. Okay, number 2, we're going to do the same process, but now the denominator is squared, so we have a different parent function. We got a reflection. Okay, so my asymptote is at x equals 2. D and E does not exist. My horizontal asymptote is at y equals 5 because of the up 5. Now, by picking these x values, any dilation, reflection, any non-rigid transformation, well, that's not true. Let me rephrase that. Sorry, because reflections are rigid. Really, any transformation, if I calculate these values, will be taken into account, and I don't have to worry about thinking about the parent and then where does it shift to, where does it reflect, where does it dilate. I can just calculate my y value. So -1 over 1 minus 2 squared plus 5 is -1 over -1 squared plus 5. That's positive, so we've got -1 plus 5 for a value of 4. Do the same thing with 3. I'm going to take a shortcut here. And this is 3 minus 2. That becomes +1 squared. So I still get 4. They have to be, because it's the parent function of 1 over x squared, I would expect these y values to be the same. So that's good that they are. Approach your asymptotes. That's a little pointy. Try to make it more curvy than that. All right, the domain is all reals. X cannot be 2, but the range is special because both pieces are below the asymptote. The range is y is less than 5. For our n behaviors, for a rational expression, they will always approach your horizontal asymptote. That's the definition of the horizontal asymptote, so that's good. Transformations, we've got reflect over the x-axis. We got right 2 and up 5. So filling in, when f of x is this parent function, g of x is -1 f x right 2 up 5. You don't have to write the 1, you can just write negative f of x minus 2. But if you want to put the 1, that's fine. Okay, so for now, for 3 and 4, we're going to go the other way. Given this transformation notation, we're going to write out the function and state the transformations. So g of x is, if my parent function was 1 over x, then it's going to become -3 over x minus 7 plus 1. Okay, the transformations are a vertical dilation of 3. Reflect over the x-axis because of the negative. Right 7 and up 1. All right, let's do the same thing for G. For B, sorry. Now that x is made negative, down 5. So this reflection is reflect over the y-axis, and then down 5. When you have your parent function of 1 over x, and we reflect over the y-axis, the pieces switch this way. So there is a visual difference for 1 over x for the reflect over y-axis than it is for the original. But it looks like it could be the same as reflect over x-axis. This piece reflects and this one reflects. So if you're given the equation, not the transformation equation, but just the equation, you could really say either reflection. But if you're given this transformation notation, when the x is negative, that has to be reflect over y-axis. When the coefficient is negative, that has to be reflect over x-axis. Okay. Now we've got 1 over x squared, same idea. 1/2 times, and I'm gonna show you another option for this. You could write your equation that way. Your x plus 3 has to be inside the squared. If you wrote this as 1/2 over x plus 3 squared, that's correct as well. State the transformations. Vertical dilation of 1/2 and left 3. Now for B, the 3x, so g of x is 1 over 3x squared plus 7. So we've got the up 7. And now it's a horizontal dilation of 1/3. It's always the reciprocal value of the coefficient when it's a horizontal dilation. Okay, now for 5 through 8, we're going to, given these transformations, write the function. You have to pay attention to what the parent function is. So g of x is reflect over the x-axis, translated up 8 units. So for 6, vertical dilation of 4, and then 5 left. So x plus 5 squared. Okay, now we're back to 1 over x. Horizontal dilation of 3 means a 1/3 times the x down 7. Okay, and then for 8, five units right is -5 inside the quantity squared, but then reflected over the y-axis, well, that has to be inside that squared quantity as well. So it's either negative of the parentheses x minus 5 all squared, or you can write that as negative x plus 5 squared. All right, I think we got 2 more graphs till homework. Let's see. Yep. All right. Oh, same as the beginning. Okay. This one has a vertical asymptote at x equals 0. Horizontal asymptote at y equals 3. Does not exist. All right, so 1 unit left, 1 unit right. Substitute in -1. +1. Dash my asymptotes. On the assessments, we will be looking for your dashed asymptotes. You must have them there. So the domain is, oops, all reals, but x cannot be 0. The range is all reals, y cannot be 3. X goes to negative infinity, y goes to 3. X goes to infinity, y goes to 3. This way. The transformations, we've got reflect over y-axis based on the negative placement, up 3, and a vertical dilation of 2. So g of x is vertical dilation, reflect over the y-axis, up 3. All right, last but not least. 10 over x plus 1 squared minus 4. So what makes the denominator 0 is negative 1. Oh, yeah, you can see that. So my vertical asymptote is at x equals negative 1. Go 1 unit left, 1 unit right. So we've got a huge dilation, no reflection. So by substituting in these values, when I calculate the y's, it's going to take into account the dilation and all the translations. So we've got 10 over negative 2 plus 1 squared minus 4, which is 10 over negative 1 squared minus 4, which is 10 minus 4, so that is 6. Oops. When I substitute in 0, that's 0 plus 1 squared, so I get 10 minus 4 again, 6. It's the vertical symmetry kind of graph with this quantity squared in the denominator, so I would expect those to be the same. That's just like a mental sanity check. So let's go negative 2, 6. 0, 6. If you want another value, especially with this large dilation, I could substitute in 1. So let's see, that's 1 plus 1 squared, that's 2 squared, 4, so then let's write this down. So 10 over 4 minus 4, which is 5 over 2 minus 4. So then I want a common denominator. So that is negative 3 over 2. It's like negative 1.5. And I know it has this symmetry, so I can go this way. And on the assessment, we're gonna say you just need 1 point on each side of the asymptote. So if you didn't calculate this, it's okay. The whole unit's fractions, so you have to get used to these fractions. All right, let's do our properties. All reals, x cannot be negative 1. The range is above the asymptote, so y is greater than negative 4. And behavior. All right, our transformations. We've got a vertical dilation of 10, left 1, down 4. So our notation is times the function of x plus 1 minus 4. And I didn't point this out earlier, but when you have the x squared here, you do not put the squared in this type of notation with the functions. This is just laying out what the different transformations are, and I have to have reference to what this f function is, otherwise this doesn't tell me what parent function I'm basing it off of. Like if I didn't have this, I could have a radical expression for f. Like, I don't know. It could be exponential. It could be quadratic. I don't know. So you have to have this parent function notation to write it in this transformation notation. So for your homework, on the next 2 pages, only do the circled problems. Don't worry about the boxed ones. It's just the ones with the circle.